Hi, welcome to Misaligned Learning. I'm Jackie, and today we're going to talk about triangles. So, we're talking about triangles when we're dealing with production modeling and a pipeline where our mesh is going to be smoothed. So, most of us probably know that we want to model in quads. We never want to model in n-gons, which is a shape that's more than four sides to a face. But triangles are a little more of a maybe. Call them a sometimes maybe. Triangles actually don't pose any technical issues when we're talking about smoothed mesh. When we have a triangle, once it goes through the smoothing process, it's going to get subdivisions that actually turn that triangle into a collection of three quads. So we're fine here. And then if we increase the subdivision level, you'll see that it just continues to flow that topology through those subdivisions so we continue to have quads. So the triangle actually is going to deform perfectly fine as far as we're talking technically. So the question becomes aesthetically and when this is going to pose problems on our mesh. So let's talk about a couple examples of different mesh forms and where we might need to consider if using triangles is going to cause any problems. Okay, so here we have some cylinders. This cylinder is a standard default cylinder that you would bring in from Maya. I have deleted the bottoms of these just for our demonstration purposes. But we can see here that the top is a series of triangles that are all converging to a point. So now if we were to smooth this out, what you'll see is that it's going to cause some issues in our topology. Now this is with two subdivision levels. Let me set this to 1 and turn it on so we can see what's happening here. So this is doing just what it did before, where it's turning our triangles into a collection of three quads. But because of the smoothing process, we get this starburst effect where these edges are going to have different resolution and also not be flush with the surface. Now in this example, we have triangles, but they're on a flat surface and supported by an extra holding edge. This is going to contain them. So now if we were to smooth this, you'll see that we don't get any of that effect around. We get smoothing, but all the deformation is here on the flat surface. It's not a part of the rounding shape change. So this wouldn't be problematic. Triangles used like this would be perfectly fine. So then let's look at this other scenario. So in this one, our triangles are inside an additional ring, but this is a beveled edge. So it's not serving as an additional edge on the same surface, but it's starting to change in volume. When we smooth this, you'll see that it's still getting that starburst effect where we can see these rays coming out and a ballooning effect around it. So what the takeaway here is, what we need to make sure things are contained with holding edges if we're ever going to be using triangles on a surface like this. Okay, let's talk about triangles on spherical shapes. So this is also a default shape. Now I've deleted the bottom half, so we're just focusing on the top cap of a sphere that's been brought in by default in Maya. And the way that these spheres are set up is it's a bunch of triangles all converging here to the top. So we've got a series of triangles. Now from what we just experienced on the cylinders, if these triangles are part of where the shape is starting to change and the volume is wrapping around, we can expect to see the same problem we saw before, where we're getting this starburst effect here where they're coming together. Now, what's often asked, if we're trying to do quads, why not just delete every other edge so that this then becomes a collection of quads instead of a collection of triangles? So that's what's illustrated over here. Now this is technically not made up of any triangles. This is all four-sided faces. But now when I smooth this, what you'll see, it's more subtle, but you can see the same effect. So when we look over here, we're actually getting the same shape that we got before. we're still getting our larger triangle with a breakdown of this shape and then subdivisions running through. Now on the original triangle, this would represent 2 subdivision levels, but here we're getting it at 1, but the effect is ultimately the same. Our topology is going to flow through. All we've done is kind of move the problem over so that it's flowing through at a different scale. So here the similarity, this is that original shape, this is that original shape with these crosshairs in between, and then we have another subdivision level that works on this one because of removing that original edge from the topology. So this isn't quite solving the problem, it's shifting the problem. So let's talk about other ways that we could solve it. One option to reduce the appearance is to make the surface smaller and increase the resolution of rings around. Now the resolution would either have to have a gradual fall off or be the same throughout, but what we'll see is that because it's been contained to almost a flat part of the sphere, we're not seeing that effect. It's still there. We haven't changed the topology, but because it's so small, it's reduced its appearance, especially as we pull farther away. So changing our resolution is going to help reduce the effect of those triangles. Here's another solution. So this one has been retopologized where those top triangular shapes were flowed through so that now it's a series of quads. So now we don't have any triangles on this surface. It's just quads creating a mesh. Now the problem with this is that this tends to cause points that may pull here. Notice the similarity of the shape. This is very similar to that triangular shape that we were trying to avoid earlier when we take a triangle and we add its subdivisions. So the same effect can happen here. It's not going to pull the same way because we've created these edges, so this edge isn't going to pull out in the same manner that it did before. But because we don't have an even distribution and the surface area of each of these is different, this is going to tug a little bit at this point. So now let's talk about triangles on planes. Here are a couple different planes. This one is original clean mesh just to compare for an ideal situation. And then here's some mesh that has different triangles and other shapes with it. Now what we'll see is if I set all these to smooth, we don't see any problem in the surface. When we're dealing with flat surfaces, the topology doesn't matter very much. It matters for some other reasons, but as far as the aesthetic effect on the model, when it's smoothed and it's flat, you can get away with almost any topology. You want to make sure you don't have n-gons, but triangles are fine. But now let's talk about if those shapes are not flat, if we end up with an organic shape that has any kind of deformation. So these are those same meshes, but they've been manipulated. And if we look at these with a smooth, you can see that that different topology is going to cause a lot of pinches and pulls. Here we have a lot of variation throughout. It does not have a clean fall off. A lot of these ripples, just a lack of control. Here was where all the points were converging, and we can see that starburst effect and a bunch of pull on it. And then here was the original clean mesh, and you can see that it handles that deformation much better. So this would be the ideal situation to avoid triangles on any mesh that's going to be organic, or if you're going to do it, to make sure it at least is working with the shape or is in an area that isn't going to deform. Now this actually touches on rigging. So if your shape originally is flat, but it has the potential to be rigged and transform into something like this, then you still want to make sure you don't have those triangles, because rigging, we're really just thinking about the future and what might happen. Okay, so let's talk about how textures, which ultimately are UVs, are affected by triangles. So here we have our converging triangles example, and then the one with triangles dispersed throughout the plane. So now if we turn on a texture here that just represents a grid, and we smooth these, we can see the effects. Now all of these are just laid out on one UV tile. So there's no additional cuts throughout. And what we can see is that inside there's no deformation. The problems that we're seeing are here outside on the perimeter because we have an uneven distribution of edges, so we're getting a pull around the outside. But the triangles that exist within are not actually what's causing the problem. It's just the uneven edges. So when a shorter edge is by a longer edge, it's going to pull towards the longer edge when it's smoothed. Okay, now let's look at this example. But instead of these being laid out on one UV grid, they've been cut. So here we can see the UV cuts where the edges are bolded. This is an option that's used all the time to increase the resolution of the UV tiling on those surfaces. Now here, if I set these to smooth, we can see the effects. We have a lot of stretching and pull throughout here because we don't have an even support around where these UVs are cut. Same here, where the converging is happening because of these pulls, it's distorting it here in the center. So we can see as it tugs around these edges because they're not the same distance. But now here with our original grid, because all edge spans are the same equidistant, we don't get any of that stretching and deformation. So if we're going to be cutting UVs where any triangles exist or just uneven spacing, we have to be mindful of the stretching that may occur on the textures where we can then see those seams really clearly, and it may cause problems on our final asset look. All right, I hope that helped clear things up. Happy modeling.